Alright, for today's video, we are talking about the properties of logarithms. Now, the function y equals log base a of x is called a logarithmic function. I just want you to look at it so you know what it is. Now, secondly, there is a specific type of log that we mention from time to time, and it's called natural log. Natural log we always signify with the symbols ln. Now, it gets treated just like a log function, and it has a base of e, and we will discuss what this means later. But for now, you just need to know that there is a little e right here on the bottom right-hand corner that is its base. The first property we're going to talk about is the power property of logs. Now, as you look, here's the rule. And if you notice, everything stays the same except for the p, where the p is located. Now, if the p is located on this side, it is called the condensed side, because if you look, this side right here seems to be a little shorter than this side. This part over here where the p is in the front, this is called the expanded side. So if we want to condense it, we move whatever number is in the front to the back. If we want to expand, we move whatever number is in the back to the front. So for example, when we have log base 2 of 8 to the x, this is the condensed side, and we want to change it to an expanded version. So we're going to take this value of x, and it's going to come all the way down to the front to become right here. X times the log base 2 of 8. And this is going to be the expanded version of the same problem. So essentially, we are just rewriting the same problem. Second property we're going to talk about is the product property of logs. Now, as you look, this side looks shorter, so this is the condensed side. This side looks longer, so this is going to be our expanded side. Now, as you're looking, we have the log base b. B can be a letter, can be a number, can be a shape, we don't know. Now, as you notice, we have an m and an n. They are jammed next to each other, which means they're multiplied. So whenever that happens, they're going to get separated. The first one goes with the log with the base first. Then the second one goes with the log with the same base. And because they're multiplied, to show the same symbol in the expanded form, we use a plus sign in between. So for example, if we were given this left side, log base 3 of 9 times x, we know this is a multiplied, so we need to go through and separate it for the expansion. So since we do have two things that are going to be separated, we need to write log base 3 two times, once and twice. 9 came first, so 9 goes with the first log. X came second, so x goes with the second log. The third property we're going to talk about is called the quotient property of logs. Now, if you notice, this part looks shorter, so this is our condensed side. This side looks longer, so this is our expanded side. Now, the only main difference between the quotient property and the product property is the fact that we have our little division or fraction bar. Now, as you notice, the log base b is going to end up being written twice because we do have two things going on. M is coming first, so it goes with the first one. N came second, so it goes with the second one. The main difference is that because it was division in the condensed and the expanded form, you get the minus sign. So, if we were going to do an example, we could say the log of a over 10. Now, if you notice, there's no base here. Whenever that happens, your base is going to become a 10 automatically. It's going to understood 10. So if you need to, go ahead and write your 10 there. So now we have the condensed version because it's really short. We want to go through and expand it. So we know we have this division, so we know it's going to be a subtraction. So I'm going to go ahead and put my subtraction sign. I have two things. I know it's going to get separated, so I'm going to go ahead and write my log of base 10 twice. So I have log base 10 on the left and log base 10 on the right. Now, a came first. The numerator is going to come first. So I have log base 10 of a as my first part. 10 came second because it's in the denominator. So I have log base 10 of 10 as my second one. And there we go. All right, take a minute, pause the video if necessary, and give these a try. Okay, since we are expanding here, we have log of x times y. There is that understood times, so we need to go through and expand it. So we're going to have our log of x plus our log of y. And there we go, all done. For our next one, we have this 2 in here as well. So it's going to look the same as the first one we did, but it's going to have this little 2 with our power property as well. So log 3 is going to come first. Then we have our log of our y. We could write a 2 here, but then we're just going to have to move it. It's going to go into the front. So it's going to become a 2 log y, and because it's multiplied, we'll put our plus sign. Number 3, we do have this little fraction bar going on. So that is going to tell us we are going to need to go through and do pretty much the same thing as number 1, just put a minus sign instead. So I'm looking for a log base 7 of x, because that's the first one, minus, because we have the division bar, our log base 7 of 2. Number 4 is kind of tricky because we have the division going on, plus we have the power. So let's go through and do our division first. So we know we have log base 5 of 3. We'll deal with the 2 in a second. Our minus sign because it is the division. And then we have our log base 5 of z. Now, the 2 would be written here, but because we're expanding it, it doesn't want to be written on the corner. It wants to go into the front. So it's going to go right over here. Condensing, a lot of people tend to find easier. So we have 2 logs here with a plus sign. This plus sign is going to tell us we're going to be multiplying these 2 together. So our log of base 2 gets written one time, and then our 6 and f get multiplied together. Number 2, our clue here is that we have this minus sign. So instead of multiplying, we're going to end up dividing. So we know our log gets written one time, log base 5. Our first one goes in the numerator, our second one goes in the denominator. For number 3, we have this 3 that we have to deal with, plus we have the plus sign. So plus sign is going to tell us we're going to multiply. This 3, when we condense, wants to go right here at the end of the log. So when we do, we have our log. Does not tell us a base, so it's an understood 10, which you could write if you want. V to the third, once the 3 moves up and becomes the exponent again, times our 7. Then number 4. Number 4 is kind of tricky. We have 2 numbers in front. We have the 2 and the 3, plus we have the minus sign. So because those are in the front, the 2 and the 3 want to move to the end of the log. And because we have the minus sign, we know it's division. So we know v squared is going to go on top once the 2 moves up. M is going to go on the bottom. And because 3 was in front of its log, it gets an exponent of 3. And then we need to write our log with our base in the front. So log of base 10 of v squared over m to the third. The fourth property is the equality property. Pretty much what equality property says is if they each have the same type of log, so either log or ln, and they have the same base, then they can go away, and what we're left with we can solve like normal, which is really pretty cool. So for example, if we had log base 7 of x equaled log base 7 of 13, we would check our log and our base to make sure they are the same. And they are, which means that they can cancel each other out, and we can be left with x equals 13. Now, the next thing we're going to talk about is how logarithms and exponents can be rewritten as each other. Now, the logarithmic function is actually the inverse of an exponential function, and because this happens, the properties of the logs are derived from the properties of the exponents. And because of that, it can go both ways. So if we don't know how to solve it as a log, we can always change it to an exponential to solve it. Or if we don't know how to solve it here, we can always change it to a log. And they go both ways. Change of base. Now, whenever your base, this part right here, is not 10, either it's an understood 10 or it actually says 10. If it's anything but that, you have to do change of base, because when we go through and we plug this into our calculator is written to understand base 10. So anything else, we're going to have to do this. So 99% of the time, we're going to have to do this. So we have log. Oh, I don't like that. That log did not look right. There we go. Let me fix that. All right, so log, let's go base 7 of 4. So if you look, it becomes log. The big number is going to become for the first log. So we have log of 4. The base is going to become with the log of the second one, where these a's are going to be 10s. So we end up with log of 7 in the denominator. Now, when you go through to plug this into your calculator, depending on what type you have, if you have one of the TIs, you're going to have to put your number in parentheses. Otherwise, your calculator is going to be trying to think too much, and it's not going to see you closing it, and it's going to want you to think you're doing log of 7, and then take that and divide it by 4, when that's not what we want. So when you go through and do this, take a second. Okay. Log of 4, close parentheses, divided by log of 7, close parentheses, should leave us with approximately 0.712. Always try to do at least 3 decimal places when you have a long decimal. It makes it more exact in your answer. And there we go.